Last section. Here goes. We are going to graph systems of inequalities. Now, when I present this in whatever class, there are 3 steps to graphing an inequality. And they're the same 3 steps, whether it's a linear inequality like the first 2 examples, or whether it's an inequality based on any of our graphs from this semester. So here we go, step by step. Step number 1, I should probably leave blanks on the page for this. If I was a good instructor, I would do something like that. The first thing we are going to do is we are going to graph what's called the boundary equation. So there'll be 2 other steps. I will slide the page back up here in a moment. But the first thing we're going to do is we're going to graph the boundary equation. This is the part of the process that you know how to do. Okay, this is what we spent the whole semester doing, is graphing different equations. So none of this is going to be any different for you. So I'm going to come over here to example 1. And we are going to graph the boundary equation for 3x minus 2y. And instead of worrying about the less than or equal to at this point, we'll come back to that and talk about that in a minute. I am just going to make that an equal to 6. Now, I know this semester we have not focused too much on graphing lines. So I'm drawing on your intermediate algebra recollection. There are two really quick things you could do here. If you want to find the x-intercept and the y-intercept by plugging in y equals 0 gives you the x-intercept, and x equal to 0 gives you the y. That is a great thing to do. But I like to find the slope and the y-intercept. That's what I do. So I'm going to do that just to help me remember and help you remember. If I'm going to find the slope and the y-intercept of this line, does anyone remember what I have to do? I'm sorry? That is exactly what we have to do. We got to solve this for y, get the y by itself. So I'm going to do that first by subtracting 3x from both sides. And so I get negative 2y is equal to negative 3x plus 6. I then have to divide everything by this negative 2, which I am going to write this step for you because I don't want you to make the most common mistake on solving for y, which is this negative 2 on the right side. I have to remember to distribute that into both terms. Okay, so just don't get lazy there. That I understand we get. Maybe it's not lazy, maybe we're just trying to work too fast. So here we've got negative 3 over negative 2. A negative divided by a negative is a positive 3 over 2x. And then 6 divided by negative 2 is negative 3. Again, this is just a stroll down memory lane. If you need more of a refresher in graphing a line, because they do pop up in this homework, because it makes graphing the systems a little bit easier to only have one nonlinear thing. So if you need any refresher, just let me know. I have some videos I can link to our class and you can watch, because I know over Thanksgiving you're going to be thankful for the Perkster and you're going to want to watch more of my videos. I get it. All right, so the 2 bits of information here are, what's the slope of this line? Where do we find the slope? Yeah, it's the coefficient in front of the x. It's 3 over 2. Yes, I heard both of those things, and they were both very correct answers. And the slope is always your change in y over your change in x. That never changes. It's always change in y over change in x. The y-intercept is that number that is added or subtracted on the end of that. So my y-intercept is 0, negative 3. This value right here is the y-intercept. Is this coming back to you? Remember this? I hate to throw out lines here at the very end, but if you had me for intermediate algebra, we pretty much hammer this home quite a bit. So hopefully it comes back. So the way we graph now is we're going to go down 3. So there's my y-intercept, 0, negative 3. And then I'm just going to climb the steps. I'm going to use my slope. It's 3 in the y direction for every 2 in the x direction. That's the ratio. So 3 in the y, 1, 2, 3, 2 in the x. I'm going to make another dot. I'm going to do this a couple times because I find it very relaxing. 3 in the y, 2 in the x, 3 in the y, 2 in the x. Now don't connect the dots yet though, because we are not graphing an equation. We are graphing an inequality. So I'm going to, not meaning to make you dizzy, I'm going to just slide my page back up to my list. So we just did the first step. We graphed the boundary equation. The second step is you have a choice to make. Are we going to connect the dots with a solid or a dotted boundary? Now, this is kind of like graphing on a number line. When you graph something on a number line, if I give you like x is greater than 5, and we're graphing it on the number line, at the value 5, what are my choices? Does anyone remember what my choices are when I graph something on a number line? Open or a closed circle? What does a closed circle mean when I do that? If I fill the circle in, there's equal to, yes. And the open circle means that that is just the boundary, that's not actually equal. So it's the same decision here. The solid line you're going to use if there is equals. And then the dotted line is if there is no equal. We'll have one more step. I'm going to slide this one more time. So again, not meaning to get to make you dizzy, motion sickness or anything like that. So this problem right here that we've been doing, what am I going to use? Am I going to use a solid or am I going to use a dotted line for this? I'm going to use solid. That is 100% correct. And again, just to point out why, I'm using the solid because of the little equal bar that is right there. So this equal bar right here determines that I am going to use a solid line. So here we go. This means that these points not only form the boundary, but they are also part of the solution to this inequality. So there's my boundary. The last step is the following. I have now done the boundary, and what this means is I've divided the Cartesian plane into two halves, and it's either the points up here that are my solutions, or the points down here are my solutions. Now, please do not do the following. Do not say, oh, less than or equal to, that means I'm going to shade below, because that is not always true. You'd be right half the time. So what you've got to do, last time I'm going to slide this, what you're going to do, step 3, is you're going to test a point not on the boundary. You're going to pick a point on one side of the line or the other, and you're going to use that point as a representative of all the points, and you're going to determine, is it a true statement or a false statement? Meaning, is this one of the solutions or is this not one of the solutions? Now, it absolutely does not matter what point you do pick. I like to pick, for convenience sake, 0, 0 when I can, because I'm lazy and multiplying by 0 is 0, but you can pick anything you want. And if you don't believe me that you can pick anything you want, pick something different and we will come to the same conclusion. So I'm going to test 0, 0 right here, where the tip of my pen is. That's where my test point is. So I'm going to come down here where I have a little space. I'm going to test the point 0, 0 in my inequality. The inequality is 3 times x, so 3 times 0, minus 2 times y, so 2 times 0. And I want to know, is that less than or equal to 6? Well, here's the value I'm picking: 0, 3 times 0, 0, 2 times 0, 0. So I have 0 on the left. I have 6 on the right. Is this a true statement? Is 0 less than or equal to 6? That is true. So what that means is the following. Again, tip of my pen. I got a true statement. That means it is a solution. So what that means is all of my solutions are going to be up here. If I had gotten a false statement where the tip of my pen is, if it had been false, that would mean that it wasn't a solution. And where would my solutions be in that case? Down below on the other side. Okay. If you don't feel confident, you can pick more than one test point. It is fine. If you want to confirm, pick the point 5, 0 or 10, 0 and plug that in. You're going to get a false statement down here because these are not the solutions. So the last thing you're going to do is you're going to let everybody know where all the solutions are. So I just do a little light shading here. And there we go. Yo. That is why, this is a great question. So in case you did not hear this on the video, the question was, hey, we didn't flip the sign even though we divided by a negative over here. This is why I treat this as an equation. I don't want to mess with that. Okay, so that's why the only time I think about the inequality is at the very end when I am testing. I graph the equation. That way I am not confounded by should I flip the sign here, should I not flip the sign here, and then it simplifies things a little bit. Did they answer the question for you? Or no? Well, if you were going to have the inequality sign in there, you would have to flip the sign here. And I would suppose you'd be doing that so that you would use whatever this inequality here was as your test. So in my opinion, that's just doing a little bit of extraneous work that is not necessary for this problem. So if you did want to work with the inequality, yeah, you'd have to flip the sign at this point and it would become a greater than or equal to right here. And then when you tested this equation right here where my finger is, you would have a greater than or equal to at that point. It'd be a fully wonderful thing to do, but again, I choose to avoid that. Okay. Any other questions? That was a lovely question. Well, do the same thing then with exercise 1. It's another line. So I'm going to put it in slope intercept form, but if you want to graph it another way, feel free. And we'll connect in a couple minutes. I'm going to get started. If you're still working, keep working. If you have any questions at all, please ask it as we finish up this content for the semester. So first thing I'm going to do is I'm going to graph the boundary equation. So I'm going to take the 4x minus 3y greater than 6, and I'm going to just graph 4x minus 3y equals 6. I'm going to solve this for y. First thing I'm going to do is subtract 4x from both sides, and I get negative 3y is equal to negative 4x plus 6. I will then divide everything by negative 3. And here's what we end up with. Negative 4 over negative 3 is positive 4/3 x. 6 divided by negative 3 is minus 2. So I have a slope of 4 over 3, 4 in the y, 3 in the x. And then I have a y-intercept of 0, negative 2. There's my key bits of information. And I will go ahead and use that to graph. So 0, negative 2 down there, 4 over 3, that's 4 in the y, 1, 2, 3, 4, 3 in the x, make a dot. 4 in the y, 1, 2, 3, 4, 3 in the x, make a dot. That's step 1. Step 2 is I have now a choice to make. Am I going to connect these dots with a solid or a dotted line? Dotted, because this time there is no equal bar on my inequality. So it's going to be a dotted line. So let's see if we can do this. Perfect. That's a great dotted line. Love it. There we go. And then the last thing is to determine which side of the dotted line am I going to shade. Are my solutions above the boundary or are my solutions below the boundary? Well, again, you can pick any point that is not on the dotted line, okay, anywhere. I like 0, 0 because I'm mathematically lazy, so I'm going to put that in. So I have 4 times 0 minus 3 times 0 is greater than 6. 4 times 0, 0, 3 times 0, 0. So I have 0 is greater than 6. Is that a true or a false statement? That is false. So what that means is my test point was right here at the origin. I got a false statement. So does that mean I'm going to shade up here, or does it mean I'm going to shade down here? Down, yes, because this is where I would get a true. So if you want to verify that, pick 5, negative 5 and plug that in, and you will most definitely get a true value. Okay, that's everything. We're just gonna, the rest of our problems, we got like a little less than a half hour left to use as much of the time as we can. What the main point of the rest of the problems are is we're just going to review some graphs that we've seen throughout the semester. Example 2 for you. Here's what I want you to do. I want you to graph the boundary, and then want you to connect the dots with either a dotted or a solid line, and then pick a test point and shade. Okay, so that is going to be some version of one of your basic graphs we've had this semester. Just a little nudge, I'm not ready to do the problem yet, but if I have y equals negative x plus, or negative x squared plus 2, what 2 things are happening to my basic x squared graph on this example? Okay, the plus 2 means it's going up 2 units. That's fantastic. What's the other thing that's happening? All of my y values are negative, so it reflects it about the x-axis. So yes, y values, negative. And if you remember, when we've done this in the past, my recommendation to you was first do the multiplication, make all the y values negative on the basic graph, and then raise that graph up too. So if you were struggling on what to do next, there it is. That's how you graph that negative x squared plus 2. So I don't know what your process is as you've learned this, hopefully over the course of the semester. What I would do if I were you is I don't have my pencil, so I'm gonna make some black dots and then I'll use a different color for the graph. So my basic x squared graph is there's a point at 0, 0, so that y value is gonna stay 0. Then remember the basic graph, when you go over 1 squared is 1, but then when I make that negative, it becomes -1. When I go over 2 squared is 4. When I make that negative, I go -4. 3 squared is 9, but when I make it negative, it's now -9. Same thing going to the left. -1 squared is 1. When I make it negative, it's -1. 2 squared is 4. When I make it negative, it's -4. And then finally, 3 squared is 9. When I make it negative, it's -9. Now, that's not my final graph. Those black dots right there are just the negative x squared part of the graph. Now, what I need to do is I need to bring that whole thing up 2 units. So I'm going to lift up each of these points. Now, if you're to the point in doing this where you can do all this in one step, I am happy for you, and do that by all means. But probably my guess is most are not. So the green dots are the new graph. Now I'm going to connect those green dots that represent the y values made negative and then moved up 2. Am I going to use a solid line or am I going to use a dotted line to connect them? Okay, there is no equals on my inequality, so I'm going to use a dotted line. So here we go. Dot, 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 dot. That is an amazing dotted line parabola. I'm so proud of myself today. Anybody got a question? I know it's been a while since we've graphed a parabola and we've had to do all the transformations. Again, it doesn't matter what point you pick, just make sure that point you pick is not on the boundary. 0, 0 is not on my boundary, so I'm going to test 0, 0 again. So here goes, we're going to test the point 0, 0. So I plug 0, 0 into my inequality. The y value is 0, less than -0 squared plus 2. -0 squared is just 0, so I have 0 is less than 2. And 0 is less than 2. That is true. Woohoo! So what that means is my test point was right here where the tip of my pen is. I got a true statement. That means all the solutions are inside this parabola. So I'm just going to do some light shading here. And there we go. That's my answer. If I had gotten false for my test point, then I would have shaded outside like it's a ray of sunshine. All right, we're just practicing exercise 2. It's just a different graph. It's the same process. I'm going to give you a couple minutes to go through exercise 2, please. If you have a question, please bring it up. I want this last test that you take a week from today to be amazing. Just a little nudge, when I do the boundary equation, I've got the equation x squared plus y squared is equal to 16. What is that? We were just talking about that a few minutes ago. What kind of figure is x squared plus y squared equals 16? It's a circle. Yes. Okay, so keep going. It's a circle. Just incorporating something we just did a moment ago. So this is just a circle. As we said, the center of this circle is 0, 0. The radius of the circle is 4. We did this in the very last section that we talked about. So I'm just going to go 4 units in each direction from the origin. When I go to connect the dots of this circle, am I going to connect the dots with a dotted or a solid line? It's going to be solid because of the equal bar that's right there. So it's going to be solid. So I'm going to do my best to draw a nice solid circle. Oh yeah, you would have thought a compass did that. That's amazing. All right, and so now I'm just going to pick a test point. Again, I'm just saying the same things over and over so that you hopefully will remember them. You can pick any point you want that is not on the boundary of the circle, and 0, 0 fits that qualification. Okay, if you've picked another point, we will come to the exact same conclusion. Our shading will be the same no matter what point you pick the test. So when I put 0, 0 in, I got 0 squared plus 0 squared is less than 16. So that's 0 is less than or equal to 16. That is a true statement. 0 is less than 16. So that means you're going to shade inside the circle. So there's my lovely shading. All right, so that's graphing inequalities. Does anyone, before we turn the page and we finish up, does anyone have any questions about graphing inequalities? Because when we are solving our system of inequalities, all it is you're going to do the same thing twice. So I'm going to work example 3 with you, and then with whatever time allots, we'll do one or both of the remaining exercises. So example 3 gives us 2 inequalities. The first one is linear, the second one is quadratic. We're just going to graph both of them on the same axis. And then the solution is where the 2 overlap. That's going to be the answer to the question. So here goes. I'm just going to slide my work down a little bit. Let me see if I can zoom out so that you can kind of see a little bit of everything. Okay, that's a little bit better. Okay, we got a little bit of room here. So the first inequality is x plus 2y is greater than 8. So I'm going to graph the boundary equation, x plus 2y equals 8. There's nothing new going on here that we didn't see on the first page. I'm going to solve this for y by first subtracting x from both sides. And so I get 2y is equal to negative x plus 8. Divide everything by 2. And I get y is equal to, well, I've got a negative 1 divided by a positive 2. That's negative 1/2 x. And 8 divided by 2 is plus 4. My slope is negative 1 over 2 or 1 over negative 2. Just put the negative with either the numerator or the denominator. The y-intercept is equal to 0, 4, and I'm ready to graph that line. So 0, 4 is the y-intercept. I'm going to make a dot there, and then negative 1 over 2 is down 1, right 2, down 1, right 2, down 1, right 2. One more time, down 1, right 2. Since my original inequality had a strictly greater than, I'm going to connect the dots with a dotted line. So here goes, dotted line. Something like that. And now I have to test to see where I'm going to shade. So as is my habit, I'm sure you're fully expecting it now. We're going to test 0, 0. And when I test 0, 0, I get 0 plus 2 times 0 is greater than 8. That is 0 is greater than 8. That is a false statement. 0 is not greater than 8. So that means here is my test point where the tip of my pen is. And so that means since I got a false statement, I'm going to shade up here. Just because I'm able to, I'm going to grab a different color pen to do the next part. So let's get a nice lighter color. We'll do this with orange, very fall festive. So the next inequality is 2y is greater than x squared. So I'm going to just come down here. So that's going to make my boundary equation 2y, whoops, that's not what I said, 2y equals x squared. So that is going to be y is equal to 1/2 x squared. Well, only one thing is happening to that basic graph of x squared. What's the one thing that's happening to my basic x squared graph right there? Yep, we're going to multiply the y's by 1/2. Okay, so it's stretched, or in other words, shrunk by a factor of 1/2. Yes, that's exactly right. So I'm going to go through my basic graph of the parabola. I am going to multiply all the y values by 1/2. So at the origin, 0, 0, that y value 0 times 1/2 is still 0. When I go over 1, 1 squared is 1, but 1 times 1/2 is 1/2. When I go over 2, 2 squared is 4. 4 times 1/2 is 2. When I go over 3, 3 squared is 9. 9 times 1/2 is 9/2 or 4.5. And I'll go one more just for kicks. 4 squared, 16. And 16 times 1/2 is 8. Same thing backwards. I got 1/2 here. I'm going to have 2. I'm going to have 4.5. And then lastly, I'm going to have 8. So it's the same points, same y values, sorry. Again, I do not have an equal, so I'm going to dot that up. So dot, 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 dot. Uh-oh, for the first time, I cannot test the point 0, 0. So somebody else throw out a test point for me for this parabola. I'm sorry, what'd you say? 0, 5, you want to use this point right here that I'm pointing to. 0, 5 is what I heard. Again, you can pick anything you want to. So I'm going to test, sliding down here, I'm going to test the point 0, 5, which is what I was told. The x value 0, the y value 5. So when I do that, 2 times 5 is greater than 0 squared. 2 times 5 is 10. Is greater than 0. That is true. 10 is greater than 0 every time. So since I got a true statement for my test point, I'm going to slide back up to the graph. My test point was 0.5 where the tip of the pen is. We got a true statement. So I'm going to shade this way inside the parabola. And then last but not least, I'm going to shade. The shading is right in there in where the two things overlap. So that is nice hot pink. So I'm just doing a little bit better shading. This is the solution to the system. It's where both shadings occur, and you just keep doing that. Exercise 3 should go fairly quick because we have a basic parabola that's been shifted, just one translation. And then we have a, in case you don't remember, we have y equals 4 is a horizontal line. So go ahead and graph that. I'm going to give you a couple minutes, make as much progress on that as you can. And then I'd like to get to the last problem because it's the most fun. And I want you to have fun today. All right, just for time's sake, because again, I do want to get to that last problem. Let's do this. So here goes the first one. First boundary is y is equal to x plus 2 squared. That is my basic parabola that has been shifted, bless you, that has been shifted left 2 units. So I'm going to take my basic parabola, I'm going to shift the whole thing left 2 units. So I'm going to put this, my dot for my origin, then over 1 up 1, over 2 up 4, over 3 up 9. Same thing backwards from that point. Okay, so this is, if you still have to do the points for the basic graph, there's nothing wrong with that. Okay, I'm going to connect these dots because of the equal bar. I'm going to connect them with a solid line. So I'm doing that. I can test 0, 0. It is not on the boundary, so I'm going to do it. So when I test 0, 0, I get 0 is less than or equal to 0 plus 2 squared. That is 0 is less than or equal to 0 plus 2 is 2. Squared is 4. That is true. 0 is less than 4. So that means for the parabola, the shading is out here. Okay, that is wonderful news for me. Now what I'm going to do is the next one is y is greater than or equal to 4. So the boundary is y equals 4. I gave it away earlier and told you that y equals 4 is a horizontal line. It's a horizontal line at the value 4. So here we go. I'm just going to, here's my nice horizontal line. Now for horizontal and vertical lines, you can pick a test point, but you don't really need to. Where are the y values bigger than 4? Are the y values bigger than 4 above, or are the y values bigger than 4 below? Above, yes. 5, you can see right there. There's a 5, there's a 10. There you go. So I'm going to shade above. And so what that means, again, the solution to this is where the two shadings overlap. And so you can see on my picture, the shadings overlap over here on this edge, going outward forever in the Cartesian plane, but we're stopping where our plane stops. And then over here on this, forever and ever. And I haven't colored since kindergarten. This is fantastic. All right, there we go. Last one, exercise 4. I'm going to give you a couple minutes. We've got 10 minutes left of class. I'm going to give you 3 or 4 of that to make as much progress. We're reviewing here. That's an exponential. Okay, you might need to make a little table to graph that. And then again, we've got a parabola. The same two things are happening to this parabola as one of the examples on the first page. So if you want to flip back and look at that, it's very similar. All right, just for time's sake, sorry that we had to rush this last example. It's the most fun one of the bunch. So the first equation is an exponential equation, which we just did in the previous unit. So I'm just going to plug in, if you need to, 3, 2, 1, 0, -1 into my equation. 2 to the third is 8, 2 to the second is 4, 2 to the first is 2, 2 to the 0 is 1, 2 to the -1 is a half. And so then hopefully this looks sort of familiar. This is the J curve, or the exponential growth curve that we talked about. I'm going to connect the dots with a dotted line because there's no equals on that inequality. So here is my dotted J right there. I'm going to test the point 0, 0 because that's my habit. You can test anything, we'll come to the same conclusion. So when I put 0 in, the y value is 0 is greater than 2 to the x value 0. And so that's 0 is greater than 1. Well, that is not true. That is a false statement. And so down here, that's my test point, was where my pen is. I got false. So that means I'm going to shade up here and kind of the curvy end of the J curve like that. The other graph is -x² plus 5. We did on the previous page, one of our examples was -x² plus 2. So it's going to look very similar. It's going to be moved up 5, and all the y values are going to be multiplied by -1. So what that means it's going to look like is this. When all is said and done. When you take your basic graph like we did on the front page, and then you flip all the y values, and then after that you move it up 5. Again, I'm going to connect with a dotted line because there's no equal. So here we go, dot, 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 lots of dots here. Again, for the blue graph, I can test the point 0, 0 because it is not on the boundary, so I will do that. So the y value is 0 is less than -0² plus 5. -0² is just 0. 0 is less than 5. That is indeed true. So my shading for the parabola is right here. And so what that means, where both of those overlap, is going to be in this fun little region right here, where both the curves, there is my nice, lovely pink shading. All right, that is it.